Hi everybody, Brett from WestCon here. In this video I'm going to show you how to create an elastic block storage volume, or an EBS volume, associated with an EC2 instance and make that volume available to the operating system. If you've been following along in the series of videos, you would have seen us create a virtual private cloud, or VPC, as well as deploying our first virtual instance into that VPC. When we created that first virtual instance, just to keep things simple, we deployed it in the public subnet. So you can think of this as a bastion host or a jump box. In this video, what we're going to do is create an EBS volume and associate it with our jump box. So I've gone ahead and logged into my AWS account already, and I've selected the EC2 service. So I'm in the EC2 dashboard here. On the left-hand column, you'll see quite a few options that are available as part of the service. About midway down the screen, you'll see Elastic Block Store. I'm going to go ahead and select Volumes. And you can see here that we already have a volume in our account. This is the root volume associated with the EC2 instance that we already created. We're going to go ahead and create a new volume. So click Create Volume. And you can see a bunch of different options that we have to provide. There's volume type. There are several different types of EBS volumes that you can deploy. General purpose SSD is sort of the new standard. We're going to leave that as our selection here. But depending on what you're doing for your customers or internally, you might want to change the volume type. EBS is also priced as provisioned space. So in this case, for demos, we're going to change our size here down to only 10 gig. This will help us manage our costs for the series. And when we make this change, if you've noticed, the IOPS have changed. So the baseline performance associated with EBS volumes is 3 IOPS per gig of provision space. So since we've only deployed 10 gigs of space, then we end up with 90, which rounds up to 100 IOPS because that's the minimum. Burstable to 3,000 IOPS to help us for boot volumes and things like that. We won't dive into the details of IOPS in this video. If you're interested, you can dig into the Amazon documentation to find out more. We also have to select the availability zone where we would like to deploy this EBS volume. It's important here to note that you cannot mount EBS volumes across availability zones. So if you're creating a volume and to associate it with a specific instance, you need to know where that instance resides prior to deploying your EBS volume. I already know that our Bastion host is in US West 1B, so I'm going to leave it there. And I could build this off of a snapshot. We're not going to do that, and we're not going to do any sort of encryption. So I can go ahead and just click Create. So now we'll just give it a second. And here's our new volume coming to life. If we select it, you can see we have no tags. So it's important, again, to tag all of the resources that are taggable. So we're just going to go ahead and add some additional metadata to this that'll help us identify it. So we know it's associated with the instance. We're just going to call it data. We also know that we tag everything with a department code, and this is for the marketing team. And then in this case, we're going to add disk type as well. You might have noticed that in the root volume. And I'm just showing this as an example. The point being here that I'm thinking longer term that if you want to start automating some of your AWS environment, which you absolutely should, using tags for, in this case, EBS volumes is a great way to demonstrate how we could create Lambda functions later on or other automated functions and consume tagging information to help us make decisions on actions that we're going to perform on the resources. So an example might be run every Wednesday after or Wednesday 2 a.m. to back up all production EBS volumes. So this is how we could use this tagging. So this volume is now available for us to use, but it's not associated with any EC2 instance. So the first thing we have to do is associate it with the EC2 instance. So we're going to say attach volume. And then we're just going to get a search window here to find the the EC2 instance that we want to associate this volume with. In our case, it's quite easy. There's only a single machine running, so we're just going to select it, and it will automatically associate a device with that EBS volume. We're going to just leave this as the default and click Attach. So now you can see we've got our 10 gig volume created. we've added metadata to it with tagging, and we've associated it with an instance. So at this point, the volume is now mountable on the host itself. So what we're going to do is switch over to our SSH console and show you how this would work. All right, so I've gone ahead and logged into our EC2 instance using SSH, and at this point we can run through a couple commands on the operating system to make the new EBS volume that we created available to the operating system. The first thing, we could just run an ls-blk command. There we go. And that's just going to show us the different disk devices that are available on this EC2 instance. And if you remember, we created a 10 gig volume. We can see that as the last disk device on this host. So in this case, for the few of you may have noticed this, the device name at the operating system level is different from the device name that is created in the AWS Management console. So you just have to keep that in mind. How it's going to be different is going to be dependent on the operating system, but just keep that in mind when you're working through this. So we know that we want to use xvdf as the volume that we've created. The first thing that we have to do is define or format, for lack of a better word, this new device with a file system. We're going to use the makefs command to format this file system as in the ext4 format. You can see here we already contain a file system. I ran this as a test command prior. You normally wouldn't see this, so I'm going to have to go ahead and say yes, proceed, basically reformatting it. Normally you would just see that command complete immediately. So now this file system is available in a specific format for our operating system. We need a mount point. So in this case, I'm going to create a mount point, and we're just going to call it demo. And now we should be able to run the mount command and mount our drive. So no errors. If we run the df command, you can see it as the last file system here on the list, /demo. So now what we've done is just a quick recap, created the EBS volume in the management console, and then ran some commands on the operating system itself to make that volume available to the operating system. The last thing we have to do here is configure the operating system so that if we restart this EC2 instance, this volume is automatically mounted. Right now, if we stopped and started this, the drive would not be mounted. So we're going to unmount it first, just to demonstrate. So now if we run a disk-free command again, you can see that nothing is mounted. Now what we have to do is edit the fstab file. So we're just going to go ahead and put in some information here. The first thing is we have to give it the mount point. So we're going to mount this drive on /demo. Okay, and we are going to tell it which file system we want it to run. Oh, sorry, I did this wrong. There we go. We've got to tell it what device to mount first. We want to mount that on demo. It's an ext4 command, and then we're just going to leave everything else as defaults. Okay, so we're just going to exit and save. Now if we run a mount -a command, we can tell if we've correctly created our fstab. No errors. If we run the df command again, you can see that we've got our file system mounted and available for use. So thanks very much for watching. In this video, we demonstrated how to create an EBS volume at the console, associate it with an EC2 instance, and then use the operating system to make that drive available and mount it on the EC2 instance itself. Thanks very much.